het klaar? Okay. Hi guys, welcome to today's session, which will be about Java 9. Perhaps we can start with a quick question. Who has already looked into Java 9? Really? 3 people. 3.5. Okay. So, something about me, perhaps useful for those watching on YouTube. So, my name is Yannick De Turck. I'm a Java developer and I am the JVM Languages Competence Lead. I work for Ordina, for the JWorks unit. JWorks is the JWorks is the unit that focuses on Java and JavaScript. Apparently we have some technical difficulties with the projector. Just a minute. Apparently since quite some time we have a new projector because the previous one was malfunctioning a bit, and apparently our projector is able to play sound, but that has been muted. So yeah, I guess that's the intro about me. The roadmap of GDK 9, so around half of 2016, the feature list has been completed, and as you can see, at the end of July, we should expect the general availability of the GDK. For the time being, there is already an early release that's available for you to play with. And as you can see right here, there is a link that contains the schedule and the complete feature list, should you be interested in these. So JDK 9 apparently has quite a lot of new features, quite a lot more than I expected. And perhaps the biggest one is definitely the project Jigsaw, which contains the module system. Besides that, there is the JShell, which is kind of a shell in which you can execute Java code and see the immediate results right in your terminal. And then there are various additions to existing APIs, such as the collection API, try with resources, completable futures, safer arcs, and various other quality of life improvements. There are quite some more besides the list I have listed right there, but I try to pick out the most interesting ones for us. So let's start with the biggest one, Project Jigsaw. So Project Jigsaw is actually about the Java Platform Module System, JPMS. It was originally targeted at Java 7, but seems like it got delayed quite a bit. And this module system actually introduces a new concept, modules, as you might have guessed, which will be an addition next to classes, packages, interfaces, and all of that in Java. And with modules, we actually want to step down from monolithic jar files, and we want, Oracle wants to make Java more easily scalable down to small computing devices, while at the same time improving security, maintainability, and strong encapsulation, reliable configuration, and improved performance by actually taking the whole GDK and just chopping it into separate modules so that you can just deploy only the modules that you actually need. While at the same time, in order to reach a strong encapsulation, they want to be able to export only the packages that should be usable by external parties, so by us, the other developers, while at the same time they want to have their internal APIs encapsulated and out of reach from all the other developers. So yeah, as you can see here, the JDK has been modularized, and all the internal APIs that shouldn't be accessible for the public are now encapsulated and out of reach for us. There's also a document written by Mark Reynolds, which is listed here, the state of the module system, and it's quite a lengthy document that goes through all the different features of the system and what's it about. So if you're interested into reading more about the system, you should consult that document. So about modules, what is actually a module? One of the definitions is that it's a named self-describing collection of code in Java. So code meaning that it contains packages containing Java classes, Java interfaces, and other Java code, and data because it can also contain resources, config files, and yeah, other kinds of information, other kinds of files. And from a bird's eye perspective, it actually declares the modules that the module itself requires in order to be compiled and to be run into the JVM. At the same time, it also declares the packages that it exports itself and the packages that it wants to be accessible to other modules that they get their hands on as soon as they require the module that you're building. Versions, on the other hand, is something that's not taken into account in the module system. So that is something for a build tool such as Maven to maintain. This is a quick example of a module. So here we have, you have a module-info Java file. The name is just like that. And this file actually contains the module metadata. It should be located at the root of your source file hierarchy. I think that's the convention. I'm not sure if it's actually necessary or obligated, but IDEs also always propose to store the file right there, because otherwise you get a warning. So I presume that it's the convention to do that. And as you can see, the content is quite small. You actually have the module, which we have here called com.foo.bar, and that's how you define your module. And then you see different lines with a keyword and then either a package or a module name. So now we will go through all the different lines and see what every line does specifically. So the first one, as I said, is the name of your module. The name is actually arbitrary, so it actually doesn't matter how you name your module. And there isn't really a convention set out into stone, but yeah, it seems that the inverse URL naming schemas of packages is also advised to be used here. So here we actually just take the highest shared package of our project, which in this case is com.foo.bar, and that will be the name of our module. Next up, we have the requires statement. So whenever you create a module, obviously you will probably use other existing modules for existing APIs and all of that, and you have to define in your module that your module depends on requires the other module, and that is done via the requires statement that you see right here. So The name that you see after the requires is actually the name of the module. So it's not a specific package that you require, you just require a whole module. And by doing so, you actually get access to all the packages that the module exports. This, in contrary to, for example, referring to something on the class path, one of the advantages of modules is that everything is checked at compile time. So for example, if you were to use a certain dependency or a certain library or a certain class, and yeah, the require statement for the class is still missing, you actually get a compiler error. And by doing so, you lower the chance of running into one of the possible runtime issues that you can experience, such as a class path issue because something is missing on your class path. Something to take into account as well is that every module automatically depends on the java.base module, which is kind of the basic API of the GDK. So that is automatically added for you. So that's why you don't see it here. It's actually just as when you define a class, it automatically extends from objects. So it's done for you behind the scenes. If people have questions, you can just interrupt me if you want. Next up, we have the export statement. So with this statement, you define the packages that you want to export and that you want to be accessible to other people. For example, if you're building an API library, you only want to export the services or the utility classes that your target audience should require. On the other hand, if you have some kind of an internal API that you don't want to be accessible to others, you just don't export it. So you have to explicitly define the packages that you want to export. And it's also important that, well, as usual, only the classes or the methods that you define as a public type, only those are accessible from the outside. For example, if you have non-public, you have a private method of or a private class. It's not accessible to the outside, not even for reflection. But in order for reflection to access these classes, there is a different statement that you can use, which is the opens statement right here. So what you can tell with the open statement is that you actually make the package accessible for outside usage, but that it is only usable at runtime, so not at compile time. So people can't write code using classes exported in those packages, but at runtime you can, by using reflection, for example, create instances of those classes, which is kind of necessary for frameworks such as Spring for dependency injection, I imagine, because otherwise that would be quite problematic. Next up, we have the uses statement. With the uses statement, you can specify a certain service interface that your module can discover via the service loader, the Java service loader. And yeah, you actually describe the services that your module can interact with. And shortly after, we have the provide statement, and in here you can describe which service interfaces that your module offers, together with one or more implementations to this service loader, to this service interface. So, for example, your module can just offer various implementations for an existing interface. You can define that with the provide statement here. There are also quite a couple of other statements that I left out because they are quite yeah, they are only usable in certain use cases. And the module system is actually something quite complex, and I'm sure that you can dedicate a whole evening to modules. So the goal of this presentation is just to go through all the different features of the JDK9 without going too deep into them, just to give you some kind of an idea what to expect and what everything is about. So we have defined everything in our module file. In order to compilate our application, well, starting from JDK9, you are actually building modular jars, and it's actually the same as the usual jar that you're building, except that you also compile and store the module-info file in there. And with the file in there, it automatically becomes a modular jar. And when you have the Java compile command as that you had before, and in the example that you see right here, we are actually compiling our source code together with a module file to a directory called mods/com.greetings, and that will actually be the location to which we will in which we will store the compiled files. And what you then see that in order to run the program, to run the jar, we execute the Java command, and what you see right here is something new. It's called the module path. So right here you have to define where the module that you want to run is located. So in our case, it's stored in the mods folder, and afterwards with the -m you can specify the main module that it should run. In our case, this is just the com.greetings module, and the class that we want to execute is the main class stored in the com.greetings package. So yeah, instead of having to set up a class path, you can just link to a certain path that contains all the modules for your application. And then if you want to run it, you just have to define the main module together with the class that it should run. When compiling your application, it's also possible to add the necessary information about the method or the class that it should run, should it be executed with the Java command. And so I've also tested with Maven, and when running a Maven clean install, it seems that Maven already supports building modules. It was clearly displayed in the logs that it detected changes to the module file that I created. So I suppose that it works as well for the time being. I didn't really have to upgrade Maven or anything, so I just suppose that it's supported. I could be wrong, so don't quote me on that. And yeah, you see that after running a clean install, we just launch the module the same way that we did by compiling it manually. So something about using modular jar files, because if you were to read up about the module system, something particular that will come to mind is that they also talk about an unnamed module and an automatic module. So if you have a module, you would start to add it to the module path instead of the class path, but you're still able to add a jar file, whether it be modular or not, to the class path. And by doing so, the module-info file will be ignored. And yeah, all the code in the module that you added to the class path will actually be moved to an unnamed module. And all the packages of the module will be exported and will be readable by all the other modules. So for example, if you were to add two modules to the class path, they would both end up in the unnamed module. And yeah, something to keep in mind is that you could have problems with yeah, if you would have several packages with the same naming. Um, so yeah, that's about the unnamed module. And then there is also something called an automatic module, and you are also able to add any jar that you want to the module path, whether it has a module descriptor or not, and the JDK will convert it automatically to a module. Yeah, you could say that the name hints to that. So when a module is added to the module path that isn't actually a modular jar, the JDK will generate a name for it depending on the name of the jar file. And it will also implicitly export all the packages. And just as with the unnamed module, all the packages that will be exported will be readable to the other modules. And at the same time, the module is also able to read the other modules. This is actually done for compatibility reasons, so that your Java 9 project can add dependencies of APIs that aren't compiled with JDK 9. So this is something to keep in mind. Are there any questions about that? I think we have a question. So the question is whether this is usable in a monolithic application, if I to make it modular. Yeah, so there is actually a way that with a single source base that you can divide it into multiple modules. But I will go more deeply into that in just a couple of slides. And here we are, splitting modules. So imagine that you have this huge source base. You have a single Java project in which you have 100 packages. You're actually able to chop your application into multiple modules. And yeah, the way to do this is actually defining a folder, a directory into the source folder with the name of your module. And in there you start with your packages. So that way you can separate your APIs a bit into separate modules, and you can define the right encapsulation, which packages should be exported and which one shouldn't. And yeah, when you would build your project, it would compile into different modules. So this is probably a bit unclear. So as I said before, the JDK 9 is actually chopped into multiple modules itself, and normally, apparently, it should have been chopped into about 92 or 94 modules. So if you were to look around, so this is Java EE apparently. We also have java.sql somewhere around here. And yeah, you can see all the different modules kind of depend of other modules. And yeah, this is the clear proof that the JDK has become quite a bit more modular. So all the modules that you see in here, you can use them, you can require them yourself into your application. So this is just to give you an idea about all the different modules that have been created based on the JDK. You don't really have to know all these modules by heart. I've noticed that in IntelliJ is smart enough to propose a module that you need to import. So that makes things quite easy. And there's actually a Java command that lists all the modules that are available via the Java --list -modules command. And then you get a whole list of the modules that are available. So just to show it. So if you were to execute the Java, what was it again? List modules. Yeah. First have to set the Java version. That's not good. Probably something with my terminal. Let me see. Live debugging. Okay. Java min version. GDK 1.9. Yeah. Oh no. Okay. Java --list modules. Yeah. So yeah, just shows a list of all the different modules that you have at your disposal. Impressive, isn't it? So that's the first live demo. When talking about a module system, you might think about any of the other existing module systems, such as OSGI or JBoss modules. I haven't really had much experience with any of the two besides OSGI. And to be honest, the experience wasn't that pleasant. Might have been about my incompetence with OSGI, but yeah, I ran into quite a couple of classes not being able to be found during the runtime. That involved a lot of annoying debugging and all of that, and misery with versioning. So yeah, that about sums up my experience with those. And although the guys behind OSGI and JBoss, so guys from Red Hat were, yeah, they were taken into account when discussing the module system for the GDK 9. The module system of the GDK 9 actually shows little resemblance to these two module systems. OSGI and JBoss modules also have no direct support from the JVM, whereas the module system in the GDK actually has direct support from the JVM, since it's Oracle developing them. And something different in OSGI and JBoss modules compared to the JDK module system is that in OSGI and JBoss modules, you actually have each module being launched into its own class loader, whereas in with the GDK you have a single class loader that loads all the modules for you. So yeah, the Java platform module system is a JVM extension, and it has actually been designed to be used for something that could be described as modules. Whereas OSGI and JBoss modules have been developed with a certain use case in mind. Yeah. So something to conclude right here is that it's not based upon OSGI or JBoss. It's been developed completely separately with a different ID in mind. But both are all about modules. A couple of days ago, there was actually a blog post written by some Red Hat guys. It's the critical deficiencies in Jigsaw, and it's quite a lengthy blog post. And apparently, it's all about what's wrong with the project Jigsaw, and yeah, quite a lot of shots were fired at the team behind the module system, and that it's a big mistake to use it, and that OSGI or JBoss modules are way better and all of that. So yeah, they really wrote quite a big blog post about it. And I guess that's it's all right to do that, but at the same time you have to, yeah, you have to take it with a bit of salt, because the module system of the GTK is a new player in town. So I think that we should give it a fair chance. For Red Hat, it's obviously a competitor to the product that they are offering. There is also a second blog post, which is actually a reply on the first blog post about, yeah, taking some of the critic that Red Hat had, and taking it into consideration, and yeah, just providing a different view on all of those things. So if you're interested into Jigsaw, you should definitely take a look at those two blog posts, because they contain quite a lot of good arguments. Actually didn't completely go through the first document, because yeah, I just saw how lengthy it was, but I just skimmed through it, and yeah, some of the arguments were a bit, well, it's a bit too early to already scratch the module system of the GDK. So I think that we should just give it a fair chance and see how it will evolve, and how it will be, whether it will be embraced by the open source community or not. So just to summarize, modules are a completely new concept within the GDK itself. It shouldn't be confused with build tools such as Maven, or existing module systems such as OSGI and JBoss. And although I have the impression that the feature has been rushed quite a bit, despite that it was initially targeted at the JDK 7, apparently there are still quite a couple of promises that haven't really been fulfilled. And I think that it's that it will gain a lot of focus from Oracle to further improve it. And yeah, I'm personally interested into seeing how it evolves, and how it will be applicable to certain use cases, how we will be able to use it in web application, and all sorts of that, and whether we will run into certain complications such as we have with OSGI or JBoss modules or any other technology. So given some time, it would be interesting to reflect on how the module system actually works. I've also included a couple of links if you would be interested into learning more about the module system. As I said, it's really complex and complicated. So yeah, but Oracle has also designed it to be usable by everyday developers, so that you don't have to be some kind of a master architect in order to master it and to use it for its full potential. The next project is Project Kula, or Kula, the JShell project. So this is something cool. It's actually a REPL for Java. People programming in Python or Scala actually already have had a REPL, and with JDK 9, the Java people have one too. So a REPL is actually an interactive tool to evaluate the code samples that you enter immediately. So you can just start writing, and after pressing the enter key, the line is directly interpreted, compiled, and run, and you can immediately see the results. So it's interesting for trying certain things out. It actually supports step completion, which is useful in a verbose language such as Java. And as you write single lines, you don't have to use semicolons. Starting the JShell is just via the JShell command that you see right here. And yeah, two commands I want to give at the start is actually the /help command and the /exit command. Yeah, the /help command will list all the different commands that you have at your disposal, whereas the /exit command will just exit the REPL. I will just go through a couple of slides and then I can show off some live demoing. So as you see right here, just you just run the JShell via the JShell command. You are greeted with a small welcome message, and then you can immediately start writing code and having it interpreted by the JShell. So here we are basically doing a simple hello world via system.out println, and the string is printed directly. As for the commands, yeah, you have various commands for listing all the variables that you have defined, or all the methods, or yeah, importing packages, or opening an editor. Yeah, setting up your environment by adding something to the class path or the module path. Doing a reset, reloading stuff, showing a history of all the commands that you have entered. And there's also a way to open up a small editor that you can configure. By default, it's just some plain text editing application, and it allows you to modify the code that you have already inputted. So yeah, that's quite cool. There's also a way to save and load your session. So if you were hacking on something and you have to go get lunch or something, you can just save your session, shut down your computer, and afterwards you can just reload your session and continue where you were exactly. So some basics. In Java, you can define variables and various expressions. And what you see right here is that you define a variable as you would in a class. So for example, you can define an int I and set its value to 0. And as you can see, the JShell will automatically reply with the variable name together with its value. And if you were to access the variable directly, you see that the variable is retained. Something interesting that you will see is that when executing a certain line of code, the result is always printed. So you can see right here that when we increment the I variable, that there is actually something called $4 with a certain value, and this is actually the result of the line that you just executed. So you don't really have to you don't really always have to define a certain variable to store a value in it. But if you were to write a line of code, for example, 2 plus 2, the JShell will automatically store the result into a variable that starts with $1, and it will just increment like that. And as you can see right here, you can use the variable, the dollar variable. So that's just something to take note of. We can define classes and methods. So you can start typing over multiple lines by just opening the parentheses, the brackets. And yeah, you can just write a whole method in there. You can write a whole class in there, and afterwards you can just use it like that. By default, there are a couple of packages already imported for easy usage, because otherwise, if you were to use a specific math function, you would have to import a couple of packages. So these are the default packages. If you were to add an extra import statement, the package will also be added to this import list right here. So here we are adding an import. We are doing a static import here of the Java lang system out, and after doing so, you can just access the out.println just like that without prepending it with the system class. There exists a command for printing out the variables that you have already used. So in here we have 5 variables that that were set. There exists a similar command for showing the methods that you have created in your JShell session. This is the command for saving and loading a session. So basically you're saving to a certain file and it will just put all the commands that you have entered and store it into the file right here. It doesn't really matter the name, what name you give to the file and what extension you give to it. So yeah, you can just name it anything you want. And by executing the open command, you can reopen it and have everything loaded into your session. So you could create a couple of scripts to set up things in order to start testing something, for example. And apparently this also works for classes. So you can just use the open command here to open a certain class file. But it's actually better to just, when loading other classes, to just set them on the class path or the module path. And here with the /env command, you can add an existing jar to the class path, or you can add it to the module path. And afterwards, the classes that are exported in the module or the classes defined in your jar file are usable in your JShell session. So it's cool for, so it's useful for just testing out stuff like that. You can just add a jar and immediately start testing something, whether it's accessing a certain web service or anything like that. And finally, we also have the edit command. If you were to execute the edit command, you get a little editor that contains all the code that you've entered into the JShell session. And yeah, it just shows it. You can do some live editing, and after you save it, the session is updated with the new information. So just to give a small demo. Don't think I have to go too deep into this because it's rather clear, I think. So you launch it via the JShell command. Here we are. And by entering the help command, we get a list of all the commands together with useful information about how to use it and all of that. So we can, for example, define a new string message hi. And the line of code is immediately interpreted right here. The value hi is stored into the message variable, and we can just print it again. If we were to enter an expression that's for which we don't store the value in a certain variable, it will be stored into an automatic variable, the variable with the $sign. For example, if we had to add two strings, hello plus world, we actually have a variable right now called $3 that contains the value of our expression. We can just exit it like that. We can use it together with the other variable that we have defined right here. And yeah, you can also work with collections or anything that you want. 1, 2, 3. Then we can do a for each. For each number we want to print it. Yep. So yeah, as you can see, it's quite easy to use. If you were to make an error, oops, you just get an error as you would get into an IDE. So it's easy to fix. For example, just to show the edit command. So here we see the session that we have. Not sure if I can increment it up. And here we can just edit it. For example, we can say hi, we can say that the message is actually bonjour. Voilà. Hello, le monde. I think that's good French, right? Salut, le monde. Yeah, that should do it, and then we can accept it and exit it. And as you can see, the session has already been updated. So if we were to check the history, yeah, that's the history of our commands. But if we were to print out a message, we can see that everything has been updated. So this also takes into account the class definitions of the method definitions that you have specified. So yeah, cool stuff, I'd say. Next up, factory methods for collections. So in the past, it was actually quite cumbersome to create an immutable collection object. Do people actually know what an immutable collection object is? I see a couple of people nodding. Who doesn't know what an immutable collection object is? Yeah, of course I don't see any hands. Maybe one. So an immutable collection object is actually a collection object that you define once, and all the values in there are definitive. You are unable to add or manipulate any of the values in there. So it's actually a collection class that doesn't implement an add method, for example, for adding variables to the collection. And it's useful for defining to define a list that is initialized a single time on startup that contains, for example, a list of possible actions or some keys and all kinds of that. And yeah, before the JDK9, it was actually quite cumbersome to do this. You would actually have to create a list, for example, add all the elements, and then you had to use some collection method to make it into an immutable list. So in order to counter this, a couple of new utility methods have been added to create a list or a set or a map right on the spot. So, for example, before JDK9, we had this. We would define our array list. We would add a couple of values. Note that the list that you see right here is still a mutable list, so we can add as much elements as we want to it, or we can also just modify the values right on the fly. And then you would use the collections.unmodifiable list method in order to convert it into an immutable list that cannot be altered any longer. So yeah, it's not too much work, but if it can be done even quicker, that's always a good thing. So in Java 9, we have a new method added to lists, hash maps, sets, and the other collections called off. So as you see right here, you can just use the list or the map class that you have right there, and you can just use the off method, and then you can specify the values that you want to have in your immutable collection. And yeah, this returns you an instance of a list or a map or a set. And if you were to try to add a value to it, yeah, you would get a nasty exception because the add or the put is not implemented of an immutable collection. So yeah, you would automatically run into issues if some nasty colleague were to try to modify your collections. Yeah. So that's a quality of life improvement. This is another minor improvement, namely the diamond operator that we know of. that was introduced in JDK 7 to save us a bit of typing. For anonymous inner classes, the diamond operator wasn't always usable, and we will see why not in just a bit. So what we have right here is a method called createPackage, and we have a t specified right here. I don't think that the t belongs here, but we can just ignore it. And the method accepts a variable called package content with the type of t. And yeah, before the JDK 9, well, normally we would assume that as we define the return statement right here, so we define a new package that the compiler should be able to infer the type here as it's defined right here. So yeah, apparently this is because of non-denotable types, so types that the compiler can actually infer correctly, but the JVM can't. So yeah, before the JDK 9, this was taken into account rather defensively, because it's not always the case that the JVM is unable to infer the type. And with JDK 9, this has become a bit more relaxed, with which I mean that for the cases where the type can be inferred by the compiler, that it should be usable instead of just banning it all together. So the exact same code right here with JDK 9 is that we can actually make use of the diamond operator right here, saving us one character. Saving characters is awesome, so that's a good thing. But for example, in this example right here, we actually have a package of an unknown type with a question mark right here. And in this case, yeah, the inferred type is actually non-denotable, and yeah, you have to, for example, we have here createPackage that takes an object, and yeah, we are actually creating a list right here. We are storing the object into the list, and then we want to return an instance of the package with the inner list right in there. And yeah, the compiler gets a bit confused when we try to do that, and it tells us that that we have to define the type ourselves right here, because otherwise you get a generic compiler error that the diamond operator is not usable right here, and that we should define the type. So yeah, it's perhaps a long explanation for something just so small, but should give you some kind of a background information. We actually have an enhancement for the try with resources statement. So the try with resources statement was also introduced in Java 7, and it actually allowed to help you out a bit with closing resources. So whenever you would try to access a resource, whether it would be a file or a stream, yeah, before JDK 7 you would have to wrap your code into multiple try with try catch finally blocks, and that was all really cumbersome. It really polluted your code a lot, which is why they introduced the try with resources statement in JDK 7. And yeah, with the try with resources, you can make use of a try statement right here, in which you define the resource that you want to open, and the code inside its scope is actually able to access the resource directly. And as soon as the block inside has been passed, the try block will automatically close the resource for you. So you are able to to use anything that you want right here, as long as it implemented a certain interface. I believe it was called auto-closable. And in the auto-closable implementation, you had to write the code to clean up or to close your resource. And with JDK9, it actually went a step further, in meaning that, in JDK7, you always had to declare the resource in the try with block. So, for example, right here, we already had our reader right here. It's a buffered reader from a file reader. And as soon as we want to open it, we actually have to define a second reader that we can interact with then. And in JDK9, this has actually been enhanced so that you don't have to recreate a different variable for accessing your resource. So you can just put the variable that you defined right in front of it in there. So it also saves a bit of typing. CompletableFuture API improvements. Who here has actually used completable futures? One guy? Two? Maybe three? I've used it a couple of times when trying out the Legom framework, but that's about it. I haven't really used it myself that extensively. But they made improvements to it, so improvements are good. We like improvements. And the improvements that they added is support for delays and timeouts, better support for subclassing, and a couple of new utility methods. So let's check them out. So when creating your own completable future implementation, apparently there wasn't a way to define a concrete type that the completion states methods should return. So I'm not sure how it was done before that, but you actually have a method that your subclass should implement called new incomplete future, and it's actually named the virtual constructor because it defines a concrete type returned by any of the completion state methods. Don't really have that much experience to how it was done before that. But the key of this is that should you subclass your own completable future, you should implement this new incomplete future method right here. And yeah, you should return an instance of your completable future class. So just FYI. The method that we have right here is that you can now asynchronously complete a future, which apparently wasn't possible before that. So that's this. If you have a specific future, you are now able to complete it exceptionally given a certain duration. And you can resolve the future with a timeout exception. So right here we have a new completable future, and should it actually get completed within a certain time range, we can just complete it with a timeout exception. So here we have a new completable future that we want to go into timeout after 1 second. So I imagine that should be useful in certain use cases, unless you want to wait for a long time on when your completable future would be completed. And this is an alternative to the previous one, where the future will be completed after a certain duration with an alternative result or a backup result. So if you were to have a completable future and you want to have the feature be completed within a certain time range, you can make use of this future to complete it with a specific value after a certain duration. And then there are a couple of static utility methods for creating executors and for creating completed or failed stages and failed futures. Suppose that's useful. The underscore character. So apparently you were able to use the underscore character for naming your variables besides in lambda blocks. And it seems that they have completely banned using underscores as a keyword right now. So for the time being, we are unable to use it. Has anyone actually here used an underscore, a variable called underscore before? I don't think so, so not a big loss for the time being. But this actually might hint that future versions may introduce something where the underscore character will be used for something, whether it's as a keyword or to give it certain semantics. For example, in Scala, you can use the underscore character for unnamed variables. For example, when doing pattern matching and all of that, you can just make use of the underscore character if you weren't really interested in a certain variable, or if you just wanted to say, just take the first variable and add it to a second variable, you would just do an underscore plus underscore. So yeah, we may see something like that in one of the upcoming versions of Java. So that's cool, I guess. This is something interesting as well. Safar args. Who here has heard about Safar args? No one? Not even our most experienced architecture guys? No? Okay. So Safar args is actually an annotation that you can use to tell the compiler that your own mixture of var args and generics is safe. So if you were to have a method and its argument is actually just a list of var args, so one or more elements of a certain type, and without the annotation, if you were to define a method like that, the compiler would give you a certain amount of warnings. We will see an example in just a bit, but the compiler would give certain warnings that the method that you defined or use is actually unsafe, and that the method might actually lead to possible heap pollution from the parameterized var arg type. And this annotation, it's been in Java also since JDK 7, I believe. And by using this annotation, you can tell the compiler that everything is alright, that you actually know what you're doing, and that it shouldn't bother you with these warnings. So by using the annotation, you can just tell the compiler to shut up and continue working. And in JDK 9, this annotation is now supported on private methods, because apparently before that it wasn't supported. And there are actually two ways of being unsafe right here. So we have the safe var args annotation that we use right here on this method. But this is only just to ignore the warnings that the compiler might give us. And by adding the annotation, the compiler will also do a couple of sanity checks, it seems. And if one of the checks didn't end up being that well, the compiler would prevent you from compiling your application. But this is only one part of the story. There is also the story with var args, that you are actually able to write code and have it compile, but if you're not really too sure what you're doing, it could turn out very dirty in the end. What I mean with that is, for example, in this case, we have just a regular static void main method right here. And we call the array of 2 method right here, to which we pass 2 strings. And if we check the method right here, we can see that we accept 2 variables of the same type t, and we return the result of the sArray method of those 2 elements. And that what we see right here on the sArray method right here is that it takes 0 or more instances of type t. And the sole thing that we are doing is that we return the arguments that we have received. So how this actually works with var args is that at runtime, the variables that have been entered right here, that the compiler will actually just create a new definition of that method with the number of variables that you have added to it. And these variables are actually put into an array, but it seems that within Java you are actually unable to create a new array of type t. And so in order to compensate for this, it will actually create an array of objects. So right here we actually have an array of objects instead of an array of elements of type t. And while it may seem that everything should work all right, as soon as you execute the code right here, you actually get a nasty class cast exception right here, because it actually says that I actually have an object and you were expecting a string, and despite it being compiled, it still turns out to be a bit problematic. But that's apparently just because of how var args work internally. So little story of the day. If you ever were to run into an error like that, you might it should give you an hint of how to debug it. So the key thing right here of the save var args annotation is just to suppress the warnings, whereas the other story is more about making use of var args. So as long as you just expect that the type of your argument element is t, it shouldn't pose a problem. But you shouldn't code anything that should depend on the type of the array that you have in your var args method. But I doubt that you would use the array that much. So most cases should be fine. Just continue what you're doing. This slide kind of summarizes the things that I've just said. So var args are actually syntactic sugar that at compile time, so not runtime, undergoes a rewriting based on the amount of variables that were used in the invocation of this method. So the arguments are made into an array of type t, but it's actually impossible. So instead it creates an array of objects. And this actually poses a problem in Java, since arrays have to know their component type at runtime. So yeah, in this case, the component type will be object, and if on the places where you would expect the type to be a string or integer, for example, it will end up of you running into an ST class cast exception. But yeah, this is just a side story that I ran into myself when doing a bit of research of the var args annotation, because I wanted to know what it was about, how it could be useful. So I stumbled upon that, so I thought it would be useful to just put it right in here as well. So something more light. Private methods in interfaces, which is way lighter than the var args stuff. So Java 8 brought us default methods. So you were able to define implementations of methods in an interface class, allowing you to extend classes implementing your interface with new functionalities. Something that the Oracle did when introducing the Lambda concept. For example, for collection objects. So the collection objects such as list were extended with various methods thanks to default methods. But one of the problems was that code reuse between default methods was a bit annoying, because if you make use of if you reuse code, you would usually separate the logic that you have into a different private method that you would reuse all over your application. And yeah, since you are unable to define a private method in an interface, because it didn't really make any sense, because an interface was always implemented, and even with default methods, these methods would be used in the implementation class and elsewhere. But in order to promote code reusage, in JDK 9 they added support for writing private and private static methods in an interface, so that you would be able to write cleaner code in your interfaces. So two rather simple examples. In here we have a Java 8 class, a Java 8 interface, in which we have two methods right here, a prepare and a cleanup method. And we have a third method, the send package method right here, that takes a package argument. And yeah, the package calls the other two methods that we have right here. It does something with the package in between. But well, that's about it. But the key thing here is that the two methods, the prepare and the cleanup method, should actually be internal methods for the interface right here. And before JDK 9, you had to expose them, and so other classes using the interface that you have right here were able to call all the methods that you had defined right there. And so in JDK 9, you're actually able to change them into private methods, so that they would only be able to be used internally within that interface itself. So yeah, that's cool. The JDK 9 comes with an HTTP 2 client. So who here is aware of HTTP 2 and what the advantages are and why it's the new way to go? A couple of people. So I'm not really an expert on HTTP 2 myself, but with HTTP 2 you're actually able to make better use of resources thanks to the multiplexing. It should be the heart of the version 2.0. Multiplexing actually means that you actually combine multiple requests, if I'm right, and you put them all together or something, I believe. Just going to cheat a bit and check my notes. Pom, pom, pom. Yeah, so you can actually send multiple HTTP requests at the same time, and their responses can be received asynchronously and individually via a single TCP connection. So yeah, it should make better use of your resources. Oops. Full screen. Full screen. Okay, this wasn't supposed to be happening. Okay, refresh. I think it's all broken right now. I think my front end broke. Okay. Abort. So did I just stumbled upon a reveal.js bug, or what is this? Hop. Chrome, save me. Yeah, this. Is my URL broken? Ah, notes. Good point. Hop. Yeah. Back in business. So yeah, reveal.js people, you should fix that. Where were we? No. Yeah. So I did finish about the HTTP2 part, right? What it's all about and why it's good. So GTK9 comes with a client for HTTP2. Apparently, for the time being, it's delivered as an incubator module, which is a new concept, I suppose. So it's actually stored within the JDK incubator package. It should eventually end up under the java.net.http package. But for the time being, it's being incubated, I suppose. So it's not finished, it's experimental. I haven't really checked if there are any other features stored under the incubator package, but I suppose that there could be a couple of others. And Oracle uses this package for storing experimental APIs underneath. So with the HTTP2 client, they want to offer a user-friendly API for making use of HTTP2, and it supports the HTTP 1.1 and HTTP 2/2 protocols. It supports synchronous and asynchronous modes via WebSocket APIs, long-running sessions, and stateful connections. So I suppose that these are all features of HTTP2, of the HTTP2 protocol. I suppose that the experts on HTTP2 can confirm this. Yeah, he confirms it. All right. Next, some examples. So you create, so in order to make use of HTTP, you use the HTTP client to create a new HTTP client. Yeah, HTTP client to create a new HTTP client instance. And then you can send a new HTTP request using your freshly made client. And using some HTTP request builder, you can define a URL, you can define headers, the method that you want to make use of, whether it be get or post or put or delete or whatever. You can build your request, and then you have to define what type of body that you're expecting. So in this case, we are expecting a string body, and yeah, just use the client to send it away, and afterwards you can consult the status code and the body. I believe that for the time being, we've just used various other libraries for doing HTTP requests, or they could have been integrated within various frameworks such as Spring. But yeah, it's cool to have an API available right within the JDK itself. This is another example with the post. In here we are uploading a file, so we're getting a file and we are adding it to our post request right here. We don't really care about the body, so we are just discarding it. And yeah, this block should upload a file to a certain URL. You also have a way to do an asynchronous call, whether it be a get or a post. And yeah, when executing the asynchronous get, in this case, you can define a block of code that it should execute as soon as the response has been completed. This is an alternative example, so that instead of providing a block of code that it should execute as soon as the response has been completed, you are actually blocking right here, and you are just afterwards checking whether the response has been made correctly, and if not, we are throwing an exception. But yeah, we all know that blocking is bad and you shouldn't do it, so don't do this. But yeah, the reason why I included this is just to show that you have an isDone method on your response object, and there is also a cancel method available, and this is useful if your server also supports HTTP too, because by calling this you can stop the handling on the server side, I believe, to save resources. This is an example of setting proxy settings. I think that most of us working for different clients have to define proxy settings in your EDE or other places, so this can be useful in this case as well. An example of setting up basic authentication. I think this looks a bit similar of defining basic authentication in other modules such as security. So won't be paying much attention to this. This is something that I liked as well, process API improvements. So until now, I wasn't really aware that the JDK actually contained a class for working with processes. And apparently it was already added in JDK 5. It was supposed to be rather primitive, but it was there, and I was completely unaware of it. So starting from Java 5, you actually had a process builder API in order to offer you a clean way of spawning and maintaining processes. And in JDK 9, they built a bit further onto this API, and they extended it with additional ways of controlling and managing the operation system processes. So they added a couple of new interfaces called a process handle and a process handle.info class. And by using these classes, you can get additional information about your process. This is an example of a process that I built that will first do a list structure command, so an ls command. I'm not sure what the what the actual name is, and afterwards it will do a grep of a certain value. So what we actually want to achieve is the following command that we have right here. So we do an ls of a certain folder on my desktop, and we just want to grab, retrieve all the files containing XML, whether it's in the extension or in the name. So we make use of the process builder, and then we can pass it a first command. We can pass the directory, and so that's the ls command right here. And then we create an additional command for our grep. So we just pass it the command grep with an argument right here, the XML. And afterwards, when the results should be redirected to our system.out, which is done with this line of code right here. And as soon as we have the two processes right here, we can chain them, and we can start them into a pipeline, which we also do with the process builder. We just pass the two commands, and the result is just that it will list the result of the two commands. Yeah. This is just a simple example. This is another one where it actually waits on the result before proceeding and printing something out. So here it's while it's waiting, it will as soon as a process has been done, it will print out some information about the process ID, about the process, such as its ID and possibly other information, using the CompletableFuture API. Just some example of working with the processes. Doesn't really say that much without a specific context. This is a nice example. So here we have, we want to have a look at a certain process and check the information that's available to us. So in here I am getting the current process, which will be the Java process, I believe. And as soon as we get a reference to the process handle, we can look up the information, and we can get things such as the process ID, any arguments that it's that have been mentioned when it was started, the command itself, information about when it was started, how long it has been running, the amount of CPU duration that it has consumed, the user that has started the process. So all this information should give you a lot to play with, and to design cool stuff with, I guess. This is another use case. So it seems like using the process API, you are able to kill any process that you want. I'm not really sure how it really treats stuff regarding security, but I just tried to kill a random application, in this case Twitter, and I just go through all the processes that I have, and for each process I want to inspect the command, and I want to filter on the command so that I only end up with the processes that contain Twitter in the command. And for each process that matches that, I want to kill it. You can either kill it with a destroy or a destroy forcibly. This one is a bit more dramatic. But it actually manages to kill the process just fine. So that's also useful, I guess. Next up, reactive streams. So I'm sure that everyone here has already read the Reactive Manifesto, which has been linked throughout various presentations. It's actually It's actually a document that contains a couple of reasons about how should a reactive application or a reactive system actually be defined, and what are the things that it should keep in mind, and what should it treat, and all of that. So it's actually a big document that should be the baseline for any developers trying to implement something reactive. And Oracle is following this as well, just as Spring did, for example, with their project Reactor, or the Lagom framework, for example, or RX Java and other frameworks. So with reactive streams in the GDK, Oracle has actually provided us with a basic publish-subscribe framework in order to implement our own asynchronous, scalable, and parallel applications. It should be noted that the JDK only provides interfaces for implementing something like this, and that they don't really provide any existing implementations. So it's just up to us to implement it ourselves. The fact that there are no implementations isn't actually correct. There is one implementation for a publisher, I believe, which I will demonstrate in the code sample that I have right here. So the reactive streams feature actually introduces the flow class that contains a publisher, subscriber, and a processor interface, and also a subscription that I seem to have forgotten to add right here. And these are the interfaces that your classes will implement when designing your own publisher subscribe mechanism. So just to run through the different building blocks, we have our publisher right here. The publisher produces items for one or more subscribers to consume. And yeah, the publisher has a single method called subscribe that the subscriber will call in order to subscribe itself to a certain publisher. Our subscriber, the subscriber subscribes to a publisher to receive messages or all sorts of other information. There are a couple of methods more to implement right here. So for example, there is a method that you should implement to obtain the subscription that you get when subscribing, a method that you have to implement to treat the next item that you receive. And then there are two methods that you should implement in order to treat when a publisher is done sending information to your subscriber, or when it has run into an error. And then we have the subscription. So this is actually the connection between a publisher and a subscriber. It contains two methods, a request method, in which you have to define how many elements you want to receive next, and for each element that you will receive, it will call the onNext method right here of the subscriber, so that your subscriber can treat the element that it receives. You might wonder, why do I want to specify myself how many items I want to receive? Because I just want to receive everything that's being sent, no matter how much it is. And this is actually for back pressure reasons. So the idea here is that a publisher can be able to overwhelm a subscriber. For example, if the subscriber has to execute a complicated logic in order to treat a single item, the publisher might just be able might just be spamming the subscriber with too many items to handle, and this by specifying the amount of methods that the subscriber should receive, it allows the subscriber to become a bit more defensive, and to prevent it from being overwhelmed by the publisher, which is called the back pressure, which is also explained within the reactive manifest. And then there is also a cancel method that it can be invoked in order to cancel the subscription and to stop receiving any new messages. Oops. Lastly, we also have a processor. This is actually a combination of both a publisher and a subscriber. It actually sits between a publisher and a subscriber, and it transforms one stream and for the publisher into a stream for the other. You can chain multiple processors, and it's only the processor at the end that is being processed by the subscriber. So yeah, as you can see in the signature, it actually combines the two. I haven't really came into this processor mechanism when working with other frameworks. For example, in Lagom, there is also a publisher subscribe principle implemented, but there isn't anything being said about the processor. I'm not sure if it's also like that in Spring or any other web framework. And so you actually have the following protocol right here. So at the start, the onSubscribe method is called for the subscriber to subscribe itself onto a certain publisher, and then for each item that the publisher publishes, the onNext method of the subscriber is called, so 0 or more times. And finally, it should end with either an error or just a completion message. This is a small example with the only implementation provided by the GDK. Oops. With a submission publisher implementation right here. Is this the first slide? Yes, it is. So we have our own implementation here of a subscriber. We have a variable right here to store our subscription, and in here I have implemented the 4 different methods right here. So we have an onSubscribe method, the onNext, the onError, and the onComplete. And the sole logic that the sole thing that it's doing is actually just logging stuff and keeping track of things. So as soon as my subscriber has captured the subscription passed by the publisher, it will start requesting messages, and in this case it's only requesting one item at a time, and every time it receives an item, it's just printing it and requesting the next item. But it's actually possible to just tell it to just send me over 100 items, and to treat the flow in a different way. But in this case, only one item at a time. Yeah, and in this case, it's also treated synchronously, so the messages are just entered one by one. I could imagine that if you request 100 items at the same time, that the order might vary. So, yeah, just something to keep in mind. So this here is the setup of the whole thing. So we have our publisher, which is an instance of the submission publisher. It will send messages of the type string, so just string values. Here we define an instance of our own custom subscriber. We tell the publisher that we want to subscribe to add a subscriber, our subscriber right here. We're preparing a couple of messages for the publisher to send, and for each message that we have defined right here, we just tell the publisher to submit it to our subscribers. This is also something cool, by the way. Starting from JDK 7, you are no longer forced to convert your collection to a stream before calling certain methods. And they've added a for each, for example, directly into the list. So this is also a cool quality of life improvement right here. I'm just doing a small thread sleep right here, just to simulate the messages being sent and being handled by the subscriber. And afterwards, the publisher is closed and the subscription is ended. And we can see that first we enter the unsubscription method right here, in which we receive this subscription instance, which is stored by the subscriber. And the items of our lists are sent and received by our subscription. And at the end, the onComplete method is called. So, any questions about that? Ah, okay. So, available in Java 8. Ah, okay. Yeah, I just stumbled upon it. I thought you would always had to go via stream before being able to call it. Okay, so for each available since JDK 8 actually. Thanks for noting. This is a lot of text. Just to summarize the whole flow of the mechanism. So it would have been better to have drawn a schema from this, but this could be used as some kind of a cheat sheet. So just to run through it once more, we create our publisher and a subscriber at the start of our flow. The subscriber subscribes onto the publisher. The publisher will create a subscription and pass it on to the subscriber, which stores it. And then the publisher starts sending multiple messages to our subscribers. And as soon as the publisher has run out of messages to send, it will just finish things up, either in a clean way or by sending an error. And yeah, before that, the subscriber also has the option to end the subscription by just calling the cancel method on the subscription. So that's that. Optional class improvements. So JDK 8 also introduced the optional mechanism. So basically, optional is just a wrapper around an object instance, and it allows you, it offers you a different way to work around null values. So for example, if you had a method that would return a string, if someone else uses the method, the person would just inspect the method and it would see, the method is returning a string, but the person has no clue at all whether it's always the case that a valid string will be passed. For example, in certain use cases, the value null could be returned by this method. And if the person is not aware of that, they will eventually run into a null pointer exception when the application is running into production, and that's not good. At the same time, you don't always want to do null checks every time you're calling a different method. And the optional is also a solution for these types of use cases, in the way that you could define a method that returns an optional of a string, and people that try to use your method immediately see that, okay, so this method might or may or may not return a value, and they can treat it immediately. Kind of the same as with checked exceptions, that the person is actually forced to treat the exceptions should they produce themselves. So that's about optionals. So the optional clause has actually been extended with a couple of new methods. We have a stream method available, an if else or present, and an or method. We will inspect them one by one. So first we have the stream method right here. So given an optional, any optional at all, you can have it convert to a stream containing the value or just an empty stream by using the optional.stream method right here. And this is actually usable combined with a flat map. So imagine that we have a service to look up a blog post given a certain category, and the service returns an optional stream of blog posts. So a stream of optional elements that could contain a blog post or not. It's a bit of a weird use case, but it's just to demonstrate the usage of this. So we call the service right here to look up the Java blog posts. And what we're then interested in is into filtering out all the empty values. And in Java 8, we were forced to first do a filter to rule out any optionals that were empty, and then to just map them in order to retrieve the remaining values. And in JDK 9, that process has been streamlined a bit. You can actually just take the stream of optionals that you receive right here, and you can just call a flat map on it and pass the optional, the stream method of optional just to retrieve a stream, whether it's empty or not. And yeah, so it just saves a line of code. Was that clear, that part? This is something more usable in my opinion. So up until now, when working with optionals, you had the if present, is present, and or else method available. And usually, at least in my experience, you would always combine these methods a bit. So you would first check, do I actually have a value present? And if it's present, do something with it. Is it not present, then we want to fall back on something else. And they now came up with an extra method to combine those three. So in this example, we have an optional of a number, and we are then we then want to print something out if the value is present or not. So we have our if present or else block, or our if present or else method right here, and then you just have to specify two lambdas to do something with the value if it's present, and if it's not present, to do something else. So this is another quality of life improvement, in my opinion. And the OR is an alternative to the previous method. So in this case, if the existing optional doesn't contain a value, it will fall back on a different value. So in this case, we have a block service right here, and we call define block method right here. This method will return an optional that may contain the blog post that we were after. And yeah, we want to design this part of our code so that, yeah, if the blog post wasn't found, it should consult the blog post via a remote service, for example, consulting it on a mainframe or any other remote service. And yeah, if the blog post doesn't exist there, we should fall back onto some archive of blog posts, and we can achieve that behavior with the OR method right here. If not, it would result in a lot of if the value is present and we want to keep it and proceed with our logic. If not, we want to do the call and all sorts of that. So that offers us quite a clean solution to this problem. Next up, we have the collectors clause improvements. We're almost there, just a tiny bit more. So collectors clause. 2 new methods have been added: a filtering and a flat mapping method. You might wonder, okay, we already have a filter method and a flat map method. So what's the point of all of this? So filtering and flat mapping are rather similar to their filter and flat map counterpart, but they are actually used for different scenarios. The filtering and the flat mapping is actually designed to be used in combination with a grouping by call. So imagine that you have a list of numbers, for example, a list that we have right here, and we actually want to call how many times a number is present in the list, or how many doubles it contains. So with our the usual approach in JDK 8 would be to, we could just thinking if it was actually the use case I had in mind right here. Just quickly checking. No. The thing that I wanted to do right here is the amount of numbers that match a certain predicate. So in this case, I had a list of numbers right here, and I wanted to count I wanted to count how many numbers were actually greater than 3. I'm not sure if the output that I mentioned here was actually correct. Okay, but the idea here is that with the first approach, so with the filter approach right here, you would first filter your collection based on the predicate that you specify right here, and then you would collect the result of all of that, and then you can do your group by statement to count the amount of times a certain number was present. And I think that's what we're doing right here. So in this case, we first filter on all the values that are greater than 3, with which we should only end up with the 2 5s right here, and we just count them. So there are, in the result, we see that the number 5 was present 2 times in here, but we have no trace at all about the initial number. So bear with me, the logic is a bit weird right here. The idea is actually that you want to keep track of all the keys that you have right here. And if you look at the result right here, we only see that, the number 5 is present 2 times, but you have no idea at all about the other numbers right here. And the thing that you have with filtering is that you actually perform your group by statement first, and that you will only do the filtering right after that. And the result of this is that you actually keep all the keys that you have right here. But by doing the filtering part after that, the key value will be kept. I've probably confused you guys more than anything else, but I hope my point was somewhat clear. So if the keys are important, or yeah, it kind of depends what your goal actually is. In one scenario, you would execute a filter first before doing a group by to list certain values by their key part, whereas in the other case, you want to keep a clear overview of all the different keys together with their value. So onwards to the next one, because this is all very confusing. Flat mapping. Flat mapping is the big brother of the existing mapping method. And the same, it's actually also designed to be used alongside with grouping by. In this case, we actually want to get all the different comments for a blog post category. So just to start up, we have our service that returns a list of blog posts. And each blog post has a title, an author, a category, and that's about it, I believe. So with the classic API, we would, so if we want to group each category with the total amount of comments of all the blog posts linked to that category, we would first write a grouping by, so that we would get all the different categories of the blog posts, and that we would map all the comments of our blog posts to a list, and at the end we would end up with a map of blog post comments. So each blog post category with their respective comments. So in this case we have the JUnit blog post right here, for which it has found 2 blog posts, and in the first blog post there was 1 comment, and in the other one there were 3 comments, and yeah, this is the result of all of that. Ideally, in this use case, we were actually interested into a single list containing just all the comments instead of this creation right here. And by making use of the flat mapping method, we can actually achieve that quite easily with about the same amount of code. So the sole difference here is that we also perform the grouping by statement right here. And by doing the flat mapping, it will actually flatten the lists right here into a single list, so that you end up with a single list for each key. So yeah, flat mapping magic. Stream improvements. So stream is also something introduced in JDK 8. And other improvements have been added to the stream class. Take while, drop while, iterate, off nullable. We'll also just run through these. We'll make things more clear. So this take while method on streams actually allows you to define a new stream. To take an existing stream and to take elements until a certain predicate has been matched. So in this case, we're telling it to just keep on taking elements from the stream as soon as you encounter an element that's greater than 0. And as soon as the predicate has been reached, it will stop running through the stream. So before you would have to loop through the stream yourself and check whether the predicate still matches before processing the value. This is an alternative one in which we would drop elements from the stream until a certain predicate was matched. So in this case, yeah, we just tell it to keep on dropping elements until an element greater than 0 was encountered. Not sure if this is actually correct. Yeah, okay. We'll just skip it. Okay, next up, iterate. So this is actually a method that already exists, and so this is the existing version of it, in which you have to define a seed, so a starting value, and a function in which you tell how it should come up with the upcoming number. And the problem with this method right here is that you would actually end up with an infinite stream. And yeah, if you have an infinite stream and you were, for example, running through all the values and printing them out, you would end up being stuck into an infinite loop and all of that. So they came up with an alternative to this value right here that allows you to define a predicate that defines whether a next value should be produced right here. So here we have here we are creating a stream. We start with the number 1 and we tell it to keep on generating elements as long as the next element is still below 20. And so the next element, for the next element, we always add up 2 to it. So we end up with 1, 3, 5, 7, until 19. So, well. Stream of nullable. This is something special. So with stream of nullable, you can pass a value and it creates a stream for you. If you pass it null, it creates an empty stream for you. You might just think, so yeah, okay, that's cool. What's the point of all of this? And the point is that it's usable in specific use cases. Again, with our dear friend FlatMap right here. And the idea here is that imagine that we have a method that may or may not return a value or null, and we want to access a variable on the object that we are expecting, and we want to do something with it. In this case, we are trying to look up a blog post and we want to access the comments of the blog post. And yeah, we want to avoid running into a null pointer exception. So in order to avoid that, we would have to check whether the blog post would be null, and if it's empty, we have to treat it ourselves. Whereas with this of nullable method right here, we can just say, just get us a blog post, and then we'll just use the stream of nullable as a safety net in order to either get the comments or just do nothing with it at all by combining the stream of nullable together with a flat map right here. So we are wrapping the post into a stream that may or may not be empty, and if the stream is not empty, the function method right here will be applied. The function will be applied to the blog post right here. So it will either get a stream of the comments or just an empty stream. Deprecated. Deprecate is an annotation that most people will know, I suppose. Who doesn't know what deprecated means? No one? Okay. So you may have encountered methods or annotations or other things that have become deprecated since a certain version. But if the developer didn't specify any additional information about the deprecated functionality, you had no idea when the functionality had become deprecated and whether it would whether it will be removed in one of the upcoming versions. And in order to streamline this a bit better, they added two attributes to the deprecated annotation. You have the for removal attribute right here and the since attribute. And with the for removal attribute, you can define whether the method that you just defined as being deprecated, whether it would be removed into one of the upcoming versions. And so in order to tell any developers using your functionality that they should stop using it and that they just should replace it by an alternative. And with the since, you can define the version in which the method has become deprecated. So it should provide more information about when a functionality has become deprecated and whether it may be removed in an upcoming version. Or a small example, so just specify it like this. So this method, some ancient method, has become deprecated since version 1.0 of my library, and luckily it will never be removed. So JDK9 actually deprecated a couple of other functionalities, and it has even cleaned up some APIs. And also due to the modules, the modularization of the JDK itself, some internal APIs are no longer accessible by default. So there were a couple of internal APIs that you could use yourself as a developer, but it was never the point of Oracle that those, or Sun, that those APIs should be used, so they have been encapsulated now with the module system. But there are also a couple of other APIs and functionalities that are now deprecated, such as the applet API, Corba. I never used it myself, but I'm sure that there are a couple of people here who know Corba and no. Yeah, probably. There's also the explicit constructors for primitive wrappers, such as new integer, that have finally become deprecated in favor of value of and parse, observer and observable, which were just badly designed APIs. And I believe this is also a big one, the removal of the rt.jar and the tools.jar. The classes inside of that were also moved into modules that can all be required by your own module. This is just a small list, but there are quite a lot more things that have become deprecated, so it should be when upgrading to JDK9, it should be useful to consult the full list right here. There also exists a tool that you can use in the JDK called JDeps, I believe, and it will analyze all the dependencies that you have in your applications and whether they are still accessible. For example, if you were using internal APIs, the JDeps tool should take notice of it, and it should tell you that you have to replace that piece of code before upgrading to JDK 9. So is there anything else? Yeah, there are actually quite a couple of other features that I decided not to treat in here because I think that the session is already taking quite long, longer than I expected. This is another big one that may have been interesting to treat as well, the multi-release jars. So you are actually now able to release multiple versions of your own jar for different environments or targeting different JDK versions, for example, and various other functionalities. I've included a link to each of them. So if you would be interested into compact strings, for example, you are able to check it out. Unfortunately, there were also a couple of features that didn't make it, such as standardized lightweight JSON API, which a lot of developers have been waiting for, but most people make use of one of the existing third-party APIs, such as Jigsaw or another one. The money and currency API would have been useful, I guess, because as far as my experience, you are now always forced to implement this yourself or to use a third-party library for this. I have no idea whether there exists a good third-party library for this, but yeah, it would have been useful if it was integrated within the JDK, in my opinion. So finishing up, if you want to get started with Java 9, it's just as simple as just going through the site of Oracle and just downloading JDK 9, setting up your environment by just having it point to the home of JDK 9. And if you are an IntelliJ user, everything is already set up. You can just create a new application. You can set the version to Java 9 and you can just start working with it. This is also a reference to a site that contains all the different functionalities that are new in JDK 9 that you can run through once if you feel like it. So that about sums up our presentation. Are there any other questions? Yes. The local type? Yeah, so a question by someone in the audience is whether the local type inference was for version 10 or 9? No, it isn't. So yeah, yeah. So the question was whether you would be able to make use of var or vals, such as in TypeScript or Scala in Java. It was also announced for Java, but it's definitely not in Java 9. Perhaps then I hope it would be useful, would save a bit of typing. Okay. Any other questions? No. Okay. You can find all the sources, the correct sources for some of the confusing examples that seem to have remained untouched in the presentation on my GitHub right here. I have a repository that also contains the presentation together with the correct sources. So that about sums up our presentation.